Alright, just got back from the flea market, and this followed me home. So I'm not really familiar with this particular unit. I've had other units like this when I worked at HP. There's a series of them in this particular format, and there's a pulse generator that I'm familiar with that I think goes up to maybe 50 megahertz. This is a pulse generator slash function generator. I'm not sure how good it is at pulses, but it does have sine wave, triangle wave, and square wave, and pulses. So that seems pretty handy. And it has a lot of knobs and attenuators and other types of things. So I already have a kind of a cheesy function generator, but this one seems to be much nicer. And for 20 bucks, definitely couldn't pass it up. He had the pulse generator in the same format that I'm familiar with. He had that also for 20 bucks, but I didn't need one of those. And it's got this weird, it's just a sticker, weird little thing on the front here. We can peel that off sometime. Oh, I don't need to do that on camera. But let's see here, let's run through it. We have a power switch. We have, like I said, figure out what function you want. There's an external input, which is probably a trigger because there's a button here for a manual trigger. This button seems to be momentary, so it probably cycles through these. So normal, triggered, gate, and voltage controlled oscillator. So this may also double as the voltage control oscillator input. We have a frequency input with a little wheel, a duty cycle with a wheel, and an amplitude with a wheel. We have an offset with a wheel, and center click on that. There's a range selection, millisecond, microsecond, nanosecond. That's pretty cool. Complement, symmetric, a negative. Then amplitude looks like there's a minus 20 dB for amplitude. There's a minus 20 dB for offset. And a minus 40 dB for output. And that button seems to be a bit wonky. So we'll have to address that one. Here's the output. Here's the trigger output. Well, so I guess we should do what Dave says. Don't turn it on, tear it apart. Let's get the screwdriver out. So these old HP instruments open up with just one screw, which is really nice. Come all the way back. And on the back we don't have any inputs, just a power connector set for 120 volts. And let's see if I can't turn this around. And it's pretty nice. It has like a motherboard and a bunch of cards in it with lots of adjustments. Wow. Lots and lots of adjustments. Nice linear power supply. These capacitors are bad or not. They're bulgy a little bit. I think they're safe to turn on though. So why don't we see anything from this angle here. Anything written on these? Not really. Well, I haven't downloaded the manual yet, but a little bit of dust everywhere. Made in Germany. Little tag here. So yeah, Germany did some really nice pieces of test equipment. Let's see. On the side here we have a power selector. So it is down and up, which is yeah, 120. So let's put a power cord on it, see what it does. We'll use this particular power cord here, which goes into my isolation transformer and power meter. So we can see what it's doing. There we go. Let's get it out here, get it better on camera. All right. How's that? Let's turn the power switch on over here. All right. And looks like a real on-off switch. I'm drawing 0 watts, so let's turn it on. Oh, there we go. It's drawing 29.7 watts, which is 0.28 amps at 120 volts. So that's reasonable. Let's go here to sine wave, frequency. Oh, and the knobs work, so it looks like it's a working instrument. Cool. So we're at kilohertz. We can go from 1.04 kilohertz to 12.6 kilohertz. We can range it up to hertz, kilohertz, and megahertz. So we can go to 12 megahertz for the sine wave. That's very cool. Kilohertz. Yeah, 440 kilohertz. Very cool. Duty cycle set to 50. I guess that is, sine wave is always 50, I guess. Amplitude is it says millivolts. I don't see any range on that. You'd think it would go into the volts range. Maybe that's because this output switch is stuck. Can't get that unstuck. Have to look inside. And error. Pulse generation. So we go to pulse generation, it gives an error. Maybe it's, oh, maybe there's a problem with it. Amplitude, frequency, offset 0. Looks like it needs to be cowled. Well, let's put it on the oscilloscope and see what it looks like. Alright, you can see the trace over there, and we've got the scope hook up here, so let's turn it on. We did get an output. Sine wave. Frequency, kilohertz. Oh, it's doing something over there. Let's go to megahertz. So there we go. So we're getting a, there we go. Let's see here, amplitude. Oh, amplitude works. Very nice. So it's up and down. Get rid of this minus 40 dB switch. Oh, there we go. Just did it. Got it to pop out. We'll have to work on that. So we can turn down the amplitude here. Whoa, we're way too big now. Okay. So we're at 50 volts per division. Yikes! This thing outputs some juice. Yikes. Wow, this thing's outputting hundreds of volts. Yikes. Oh no. It's probably set to a times 10 it's probably set to a times 10 probe, so it's probably 5 volts. We're probably okay. I don't think I'm going to electrocute myself. Okay. So we've got frequency. Works great. And we've got amplitude, which works great. We've got a range, which seems to work pretty good. And we have an amplitude, minus 20 dB. Switch is dirty. Okay, triangle. Triangle looks good. And square wave. Square wave looks good. Very, very sharp edge. That looks nice. Very, very sharp edge. And pulse, which we can complement. Very nice. And the frequency also seems to change the pulse. Yeah, That's probably just the edges you care about. That's kind of weird. Let's see, we're on normal trigger now. We can do a trigger with nothing. Hit the little button. Yeah, hit the little button. We get a pulse once in a while. Gate triggering, VCO triggering, and normal triggering. That looks good. Yeah, I think it mostly works, so need to work on that switch. Probably spray some cleaner on all of the switch contacts. There's a little funny little adjustment down here for start phase. Yeah, I think it's a good addition to the lab. Yeah, I have to find the manual for it, maybe calibrate it. There's like lots of adjustments inside, lots of adjustments inside, so I don't think the capacitors have failed on this thing. It seems to be working pretty good. Anyway, good $20 flea market find. Okay, found schematics online and went through the power supply sections, and then I actually went through every single board. Each of the cards is an assembly, and they're all marked. There's an A1 assembly, A2, 3, 4, anyway, it's like that. So I looked at electrolytic capacitors that may live on those boards. So the A1 is actually, actually the motherboard, and there's 4 big capacitors. We saw those, so that's these guys here, microfarads and voltages. Then the A2 board is this one, and it's got some electrolytics on it, A4, 5, 6, 7, 8, and then there's some extra things laying around. And then there's that capacitor on the AC filtering that looks like it's about to blow up any second. So I bought a 0.047 microfarad X-type capacitor. If you have, it's not even shown on the schematic, but if you have a filter and you have line and neutral, a lot of times there's a capacitor across those to reduce the EMI back into the AC. And you need a very special type of capacitor and rated at the correct voltages and stuff. There's X capacitors, X-type capacitor rated at about 250 volts AC. Make sure that's an AC rated capacitor. And that's what I bought here. I bought, I think, a 250 volt 0.047. That'll go across here. If you have capacitors across line and neutral, that's an X-type capacitor. If you have capacitors from neutral to ground and line to ground, those are Y-type capacitors. They're different. I think you can use X-type capacitors and put them there also, but Y capacitors cannot be put across line and neutral. I think I'm saying that correctly. Went to DigiKey and ordered a bunch of capacitors. Here's the X-type capacitor. It's 275 volts AC rated. It's a film type capacitor, 0.047 microfarads. And so we'll be putting that on. And then I've got some like big capacitors, 6800 microfarads at 16 volts. And anyway, I got a whole slew of capacitors, and so we'll take these cards out and start putting capacitors where they go. And the function of the generator is quite good right now. It does work, but since I have it open, I know it's going to go bad in the future, so why not fix it up a bit. Okay, so we're going to replace these 4 capacitors here, and the X-type capacitor is down here. And so we'll flip it around, see if we have access to it. Yeah. So we should be able to do some desoldering across here and take those capacitors out. Okay, so I always like to put fresh solder. I think it seems kind of counterintuitive to solder before you desolder, but it seems to work out better for me that you have fresh solder on here. It flows the old solder better. So we will see if we can't. I think I need to have a larger tip on this thing. I don't know if I have a larger tip. Let me go take a look. Alright, I did have a larger tip, so I'll put that in. Oh yeah, that's going to work a lot better. And this one's on a ground plane. It's going to take a while to heat up. So. There we go. So, capacitor out. Capacitor out. These are pretty good. They're a bit expensive. This is a Heiko FR300, and they're about $300 if I remember right. I don't know, they're quite pricey, but they do work pretty good. You can get even more expensive ones, but this one has served me well. So got those out. I'll take the other ones out and I'll go to the installation. Oops! Oh, bumped the camera. Alright, so I have the capacitors in there, and we will solder them in place. Looks good. And where are my cutters? I don't have any cutters, really. Huh. Yeah, there. I'm always on the lookout for good cutters. I found these on eBay. The most amazing deal I think I've ever gotten on eBay. These are Aram cutters. They're Swiss made. This is the 576TX version. And if you go and look up 576TX, you'll notice that these have carbide inserts. So there's actually carbide kind of brazed in there. And I think these sell normally for something like $275 or something. They're super expensive. And some guy in all places, Puerto Rico, maybe the hurricane like ruined a factory and this guy got a whole bunch of cutters. He said they were rusty and that he had to actually refurbish them, so they may have gone through water. But he did a great job of refurbishing them then and put them on eBay. And if I remember right, he was selling them for $15 each. So I bought a bunch of them. Yeah, so very cool. Alright, so that looks good. We'll flip it over and start the A assembly, one of the A assemblies. Alright, take out this assembly here. Pops right out. And here are our electrolytics. It says there's 5 of them here. 1, 2, 3, 4, 5. Let's see what my list says. 1, 2, 3, 4, 5, 6. Oh yeah, there's one way over here, which is a 1 microfarad, and I'm not going to worry about that one. I don't think that one will ever go dead. So I'm just going to replace these 5. These look a little crusty already on the cathodes here. So, the negative sections. So we will take those out. 47s and a 10. Oh, 220 microfarad at 10 volt. These are 47 at 63, and there's one of those real fancy ones. I'm not sure what these, what the actual composition of these capacitors are. I want to say silver. If I remember right, there's like a weird. They were very popular at Hewlett-Packard in the way back days, and they're really super good capacitors, very low ESR, and stockrooms always had them. They're very good. Probably don't need to replace that one, but since I'm here, yep, they're all going. I bought Rubicons and Panasonics, I think. Those are the 2 brands of capacitors that I bought, so they should be pretty good. Alright, so I have all the capacitors in here, all the same color. These are actually Nichicon. Yeah, Nichicon. Very nice. Nice purple color. And reach around the camera to solder, but I think that's doable. I actually touch this one here with the desoldering. There we go, that was easy. Make sure, always visually inspect your solder joints. Make sure that the fillets have flowed nicely. And when you go to snip off your leads, make sure they don't fly into your instrument. They go someplace that you don't care. It wouldn't be good if you had a whole bunch of metal in your instrument, turned it on, and shorted things out. So, there we go. And we can put that back in here. Okay, I think you get the idea. I'm going to go through the rest of the instrument here. Maybe you want to see the cards. This one, This one has a custom part on it. I think it's a probably for the timing chip. It might be a ROM. I don't know, but it some type of custom part. This one has lots of trimming on it. I should probably say which capacitors I'm changing. On this one, looks like there's just one electrolytic here, maybe one over there. And on this one, doesn't seem to have any, actually. I think it would have one, but here it is, over on the side. There's usually one bypass, large bypass cap per board. And this one has some wires stuck onto it, so that goes to the output connectors. It also looks like it has a custom part here. Nice big capacitor here we need to change. Capacitor there we need to change. This is just socketed, so we can just pull that cable off. This is just a bunch of TTL parts. Has a 100 microfarad and something over here. Can't read it. And then this one doesn't come out unless you disconnect the heatsink, so maybe I'll film that later. There's a, couldn't see it there, could you? There's a heatsink here that connects the output transistors. These are from the pulse generator, so they generate lots of heat. They go onto this big metal heatsink here, and then it bolts onto the chassis, so that chassis acts as a thermal heatsink as well. That was quite popular back in the days when the chassis of Hewlett-Packard Instruments were all cast aluminum, so there's lots of heatsink capability in the chassis by itself. And then the front panel cards are going to be hard to get to. I'm going to have to work at that. I think I have to take all the knobs off the front and pull things off. If I want to get in there and repair those switches and clean those switches, I'm going to have to do that, so I'm not looking forward to that. Okay, we're going to try to get the front panel off. So I've done some things here. I've removed 2 screws here that are part of this heatsink assembly. I told you about that. I've taken the corners, there's one missing here. I've taken the corner screws off of the chassis. These hold this front cast piece onto these side cast pieces. And I've taken off all of the screws that hold these switches or the potentiometers in there. So it might want to come out now, or not. Oh dear. Oh dear. This might be a hard assembly to do. Yeah. Let's see here. Let's take this card out. This is the, oh, there we go. There's one, something here we have to worry about. There's a cable. So this is actually the output driver assembly. And it's not marked. So whenever you take things apart and it's not clearly marked, mark it yourself. So I'm going to mark the negative, put a negative sign here, and I'll know that the braid, goes there, so we can take these off. Let's see here. Okay, so this card comes out, and we start to investigate why this front assembly is not moving. There's like 1, 2, 3 cards. There's a card in the front, and then 2 cards that plug in, and then they all plug into a edge connector. So my guess would be that this whole thing comes out as an assembly. I think we are missing a couple screws here. These 2 screws. Those need to come out. Oh, there we go. It's starting to move. Starting to move. Yep. Alright, this is hung up. And that's hung up. There we go. Ah. You saw that. So this comes out as a whole assembly. Like I said, there's a board in the front, and then these two cards. So maybe I didn't need to do all that work on the front. I may be able to get to everything I need to from the back side, not have to actually disassemble this thing. Well, that would be nice. That wasn't too much work though. Yeah, we got a whole bunch of cards here, but we can see all of the switches here. So yeah, we can squirt some contact cleaner in those and see if that fixes it up. The one switch that was sticking was this 40 dB switch, which it does still stick. And so that one still may need some work. If I can zoom in, let you get a better look at this assembly. It's quite complicated. So these are all of these switches here, and then the switches on this side. So these are the cable assemblies. This one is for trigger, and this cable assembly goes back onto this board, and that is the output, and then it probably then comes back off of this connector. So they do a double connector, which probably because they need switching. Yeah, switching in there for the attenuator. So the output goes through an attenuator on this board, and then it goes to the actual drive here. So those are the only things that connect to the back. Everything else connects through this big connector here, which, now that this is open, you can see here. So that connector goes in here, and then the drive board sits here on this connector here, and then this is that the heatsink that connects to the front chassis. So we still have some capacitors to replace here now that we have this out, and then we need to work on the switches on the front. Alright, so I have replaced some capacitors here. These two capacitors. This capacitor seemed real flaky when I took it off. It seemed like there was a corrosion happening on the back end of it, so it's good that I replaced that one. So it's ready to go back in. The front panel is ready. I sprayed contact cleaner in the back sides of all of these switches and worked them. So they all work okay. The switch that was having problems, this output -40, still having problems, but I found that what you do is you push it in and flick it. Flick it. Oh great, now it's not going to do it. Well, it was working. Every time I flicked it, it came out. Ah! Well, more contact cleaner. Which one is it? This one. There it goes. Maybe it needs more contact cleaner. So you push it in, flick it, comes out. But only if it has contact cleaner in it, obviously. Yeah. I'll give it a nice dose here. Okay, it's working now. I don't know. maybe it'll stop working when I put it back together. But anyway, I'm not going to use minus 40 dB output very often, so maybe I won't even touch it. I think it's time to start to assemble the thing back together again. Okay, it's back together. Front panel's all back. All the cables are put in. I did miss one thing though. We do need to change the this capacitor right here, which is the X capacitor. So I need to find that, and where did it go? There it is. So we'll put that in and then button it up, try it out. Okay, so you can see the new capacitor in there, and here's the focus. Doesn't want to focus. There it goes. This is the crusty one. Oops. Better fish that out of there. Anyway, I'll put. Okay, live on camera. Turn it on. There it goes. Looks good. Frequency 2 cycle 50. Amplitude 16 volts. 1.5 to 16 volts. Looks very nice. Sine wave, triangle wave. Uh-oh. Uh-oh. It just died. Oh dear. Something died. Maybe I put a capacitor in backwards. Oh dear. Well, that's why we did it live. And maybe didn't like that. Let's see, we're 120. Yeah, it's drawing 0 current. So, something didn't like something. Okay, so I found out what I did wrong. Of course, it was my problem. There is a fuse here, and I'd blown the fuse, and so I replaced the fuse and blew it again, and then I went, I wonder how much current this thing's actually drawing, because it's only fused at 500 milliamps, and it didn't look like it was drawing current, but maybe I did something wrong. So I wanted to destroy the part that I put in backwards. So I put in a 1.5 amp fuse and watched my current meter to see how much this thing was actually drawing, and it started drawing at about 1 amp, which is way over spec, and then it started to climb. So I knew something was failing. So I figured it had warmed up quite enough that I could go around and start touching things. So I, if I had one of those IR cameras, that'd be great. You could just watch things heat up. I started putting my fat fingers around on things, and I noticed these two capacitors were getting really hot. In fact, they still are hot. And so I put those in backwards, I guess. I thought I put them in the right way. Anyway, those are the biggest capacitors in this thing, and they are toasty. So I don't think I want to put them in the right way now that I've destroyed them. I think I need to order a couple more caps and put them in the right way. But we did see it working. So these Nichicon caps work backwards for a short period of time. Good on them. So I will order some more. Those were the 3300 microfarads at 50 volts. Yeah, so a lot of power going into those suckers, and they got really, really hot. I'm going to have to go back and check, make sure all 4 of these capacitors are in the right way. Maybe I just... Yeah, maybe it's just, it's the morning, and maybe I'm not thinking straight. Anyway, but at least the thing works. I know that much, at least from the quick test that we got to do before things went south. Oh well, that's what happens. Oh, who doesn't love an HP user, service manual? So it shows these 4 capacitors and exactly how they're supposed to be installed. Minus plus, minus plus, minus plus, minus plus. And are we looking here? These two are backwards. Whoops. Anyway, I got the other two. I got the other two correct, but screwed up on the big ones. So off to DigiKey to make an order. Okay, so this is about as stupid as you get. The PC board is actually marked, plus and minus, and somehow I ignored it. Oh well. All right, DigiKey came today. I got the capacitors in. Hopefully the right way around this time. So let's go ahead and power it up and see how it works. All right, we got a good display. Looks like it's working. And let's check out the power consumption up here. Looks like there's a wire in the way, but we're at 290 milliamps, 31 watts. Looks good. I think we got a winner. So duty is there, amplitude's working, and yeah, looks great. Alright, so now we have a 20 megahertz pulse function generator, HP8111a. I think this dates around 1985. So good thing that we put new capacitors in it. I did check a couple of the capacitors when I pulled them out, and they were dead. Good thing, like a 100 microfarad capacitor was measuring about 10 and had an ESR of about 20 ohms. It was really bad. So yeah, the electrolytics definitely dried out on this. Have a nice instrument. I texted my buddy who used to work at HP as well, and he said he used to have one of these on his bench back in the Wayback days, so that's great. Anyway, I think I'll enjoy it.